In the last episode, we laid the foundation for today's app and create business configurations for document types and tags. Now we want to create our new application for uploading and creating documents. And as a first step, we only use various generators to create the data model. We already introduced the object generator in a blog post. It generates various static artifacts for us, so we don't need to specify any further settings besides the configuration. This saves us from creating tables, data elements, and domains yet. We always have a complete data model available. Therefore, as a first step, let's create a new class that will read the configuration and then generate the objects from it. In this case, we will use the executable XCO class, as it handles XCO objects better and has built-in error handling. Unlike with an interface, we inherit from the class and must first redefine the abstract main method locally. First, we create a GitHub configuration since we've stored the configuration as JSON in our GitHub repository. We pass the configuration to the test container and then retrieve the data as JSON. Since we need a structure for the data here, we define the generator configuration as a local variable. Next, we can create an instance of the object generator. Passing the variable SURapid as report ID is important because we want to derive the transport from the current class without having to pass it manually. Now we pass the configuration to the generator and let it generate the data artifacts. We then pass the result of the generation to the output of the main method. The resulting object has the interface news in its findings, which allows for easy output with the executable class. If we now go to the GitHub repository, you will find the appropriate file for the generator in the data folder. This file contains the configuration and information such as the domains with the data types, the corresponding data elements that the domains also use, and the table's definitions. For the tables, it's important that the client field is present, as are the RUP administration fields in the lower part of the table. We will generate two tables right away. The raw button gives you the link to the JSON file, which we will also pass to the container configuration in the source code. That completes the code so far. We activate the class and start the generation with F9. After a short moment, the generation should be complete without any error messages, and we can update the package. We should now find 12 new objects that were generated by the generator and activated immediately. Let's take a look at one domain. The stream type was correctly inherited. Our table for the documents is now complete and active, and we can look at the next generator. Last time we created the apps object manually. This is a very cumbersome step, but worthwhile for beginners who are working with RUP for the first time and want to learn the concepts. In this step, we will use the RUP generator to generate the objects and the stack. This saves us a lot of time, as does the object generator. We can start the generator directly on the table and will find 3 different generators. We've already used the business configuration to generate objects. In this case, we want to create an OData UI service. For the generator, we still need to specify a package where the objects will be generated. We would generally expect the package of the table to be used. The next step involves configuring the various objects that will be created. You could generally accept most of the generator's suggestions, but we want to use our own conventions. At the first level, we provide general information for the generator, the project name, and we would like to use a prefix. You don't need to specify the set for the customer namespace, and it will be added automatically. At the next level, we adjust the name of the root entity and leave the alias empty, as we don't need it. At this level, we define the behavior. Here we need to adjust the name of the class, which usually begins with a BP, such as behavior pool. We also adjust the name of the draft table. Next, we address the project level of our RUP object. Here we adjust the CoData service to match the root entity, as well as the class for behavior implementation. We want to create the service definition without the suffix and leave the service binding as is. Clicking Next generates a preview of the created objects and confirm the generation, which then takes a few minutes. Once the generation is complete, we receive a notification and can switch to the service binding. There we press the Publish button and start publishing the service. This step may also take a while. Let's take a first look at the application. The structure are defined, the services are activated, but unfortunately there is still far too much information displayed in the UI. Using the generators saved us a lot of time generating the data model and the various artifacts. Manual work would have been time consuming and could also lead to errors that we would have to correct later. We will take care of the other entity, the annotations, next time. Until then, thanks for watching and see you next time.